Okay, guys, grab your pencils and get yourselves ready to copy this down as we go. Today, okay, we're going to be looking at energy. Okay, so energy for you guys today. The first question is, what is energy? Well, actually, that's not an easy question to answer. There are lots of scientists out there, physicists, who are cleverer than I am trying to work that out. Okay, and they may well give you an extremely technical and difficult to understand answer. So instead of answering that question directly, the way you need to think about it is that when something happens, energy is transferred. Okay, and that could happen anywhere in the universe. Okay, so when something happens, energy is transferred. The other thing to think about is the idea of it being the ability to do work. Okay, that's the other way of thinking about it. The idea about work is a physics idea, not going and doing a job somewhere and getting paid for it, but work as in moving an object from one place to another, for example. Okay, that's an example of work. Okay, so let's have a quick look at a few basic ideas. Okay, and we're going to start with the idea of energy stores. Okay, so energy can be stored in plenty of different ways, some of which don't, to me, aren't that logical. Okay, to start with. So the first one that we're going to talk about is heat. So in order to get that idea, I'm going to draw a few logs and make a little campfire. Okay. And then we'll set those logs on fire, shall we? Okay, so fire, okay, obviously transfers heat energy. It also fire can be described as a store of heat. And there we go. Okay, another idea, another store, okay, is movement of, I'll just label that one, sorry. Heat. Okay, another idea is movement. Okay, now the idea of movement being a store may be one that looks a little confusing, but what we think about is when something moves, okay, as it accelerates, as it gets faster, okay, the store of energy that it has, okay, the store of kinetic energy increases, okay, and that's how we think about that as a store of energy. So this little guy here, Lorenzo the tortoise, okay, he's quite happy. He's quite happily just chugging along. Got a little tail there. His store of kinetic energy never gets particularly great because he moves quite slowly. Okay? But then if you compare him to, for example, a sports car, okay, which we might do a bit later on, a sports car obviously moves a lot quicker and has a greater store of kinetic energy. Okay, so movement. There's another one. Okay, when we stretch, for example, an elastic band, okay, or as I'm going to draw here, a bow, okay, then our store of energy increases. Okay, and obviously, again, when we release the string, that energy could be transferred, could be changed into a different type of energy. And that might be, for example, this arrow, okay, it would get shot forwards, and that store of energy in the elastic, that store of elastic energy in the bowstring will decrease, and the store of kinetic energy then will increase. And our other one is something getting lifted. So I'll draw for that. I'll draw someone lifting a dumbbell. Okay, obviously me lifting up a dumbbell there. That is obviously a massively heavy weight as well. There we go. I'll that one in purple as well. There it is. So I should label those two as well, shouldn't I? So we'll put this one, something being stretched. And something being lifted. Now, this is not, again, none of the things that we're going to go through today. This is just an introduction. So none of them are, this is not an exhaustive list of all of the stores of energy. Okay, we're going to go through some more examples in a bit more detail. We're going to look at these in a bit more detail as well. But none of it's exhaustive, okay? As we progress through all the energy topics, you will get more ideas, and your ideas will become more complex as well, more detailed. So let's have a look at a couple more. So the first one we'll do here is gravitational potential energy. Right, and so gravitational potential energy, let's draw what you'll probably all associate when you hear gravity, okay, particularly in science. Here's a nice tree, and inside that tree, falling maybe from that tree, could well be an apple. So when that apple is quite high up here, then it will have quite a lot of gravitational potential energy. Let's say it's 2 meters off the ground, okay, 2m. It will have quite a good store of gravitational potential energy. As it falls, that gravitational potential energy will decrease and the kinetic energy will increase. Okay, so gravitational potential energy simply is the potential for there being, for example, kinetic energy as it moves towards the ground. And anything that is within a gravitational field, that as long as it's not at the centre of that gravitational field, has got gravitational potential energy. You might well also realise that your head's got more gravitational potential energy than your feet, as long as you are stood up, obviously. If you're lying down, then you're not, and if you're stood on your head, then obviously not. Okay, so kinetic energy is one that we've just touched on, so let's have a little look at that. Kinetic energy is just movement, and so let's draw something that's got movement. Let's draw a fancy sports car. There we go. Oh, look at that. Sheer beauty. Okay. So there's my sports car. And again, what is it that powers that car? Well, what makes it go forwards? Well, what makes it go forwards is petrol, isn't it? And petrol is an example of chemical energy. Okay, which is another store of energy, okay, that could be found in several sources. So I'm going to draw several little pictures. The first one, as we've just looked at, is petrol. So I'll draw an old petrol pump. If I can remember how to draw a petrol pump. There we go. Okay. There's your petrol pump. Obviously, let's put that BP on there, just so we know that it's not like a telephone or something like that. Well, you don't see telephones like that anymore, I guess. So that chemical energy can be transferred when you burn it into several different types of energy. Okay, one of which will be eventually kinetic energy. Okay, other stores that we've kind of had a look at is an apple. Okay, that's a store of, it could be described as a store of chemical energy because inside it there's sugar, and inside your body you can convert that sugar into energy, and you can use that energy for any of those 7 life processes that you'll have learnt about in biology. So that's your store of chemical energy. And then another one, okay, that is becoming more and more used, okay, that is quite obviously a fantastic picture of a battery. So inside that battery, try and find a golden colour, like that. Inside that battery, particularly ones like that, you will see are lithium oxide, lithium ion. Lithium is a chemical, obviously, and we can use that chemical to make electrons move around a circuit. Okay, so you're producing a flow of electrical charge, okay, or a current, and that is again pushed along by that chemical energy in the battery. We've touched earlier on this stretched idea. Okay, so that stretched idea we will look at and name as elastic potential energy, and that's again another potential energy. Okay, that's not gravity, it's to do with the amount of energy stored in a stretched item. And then this time I'm going to draw a catapult. Okay, there it is. And obviously the back of that catapult has got an elastic band. Okay. Like that, and that's held together. It's got a little pouchy bit on the back like that. So again, when we stretch that elastic band, okay, we can make whatever is put in the holder move forwards. So we're converting that elastic potential energy into kinetic energy. Now, not all of that elastic potential energy is going to be converted into kinetic energy. Some of it is going to be wasted. Okay? And a lot of the times when we're wasting energy, it's because we're turning it into thermal energy. Okay, and thermal energy it's another name for heat energy. So we'll draw, being a chemist actually, I'm going to draw you a picture of a Bunsen burner. There you go. Don't forget the hole. Like that. And obviously we need to be safe, guys, in science, don't we? So I'm going to draw you a little bench mat underneath it. Okay. So yeah, a lot of the time we will waste thermal energy, or some of that elastic potential energy will be converted into thermal energy. It could be converted into sound again, which is another type of energy. When you hear that twang sound as that shoots its item out of it, probably a stone or something like that. Okay, so that is just a few ideas, okay, some examples of different types of energy, okay, and where we might find them. The final piece of the puzzle, okay, is that we can transfer energy. Okay, so we've looked at stores. Okay, we're going to come around and look at transfers. Okay, we could transfer energy, okay, by movement of electrical current. Okay, so obviously a bit of lightning is involved in there. Okay, let's see if I can write that in a different blue. Okay, so that could be a movement of electrical current. Okay, that can be a transfer of energy. Put another bit of light in there. Okay, we can also transfer it by heating. Now, heating, we can then look in a bit more depth. There are 3 ways that we can transfer heat energy. Okay, the first one is radiation. It's really important, radiation, there we go. It's really important not to confuse radiation with radioactivity. Okay, radioactivity is another topic, okay, which we'll talk about later. But radiation is a movement of energy, but it's a movement in as a wave. Okay, so for example, if we've got the sun, sorry, pencil. There's the sun, and obviously the sun shines, and we feel heat from that sun. But we feel heat. We feel heat from that sun. Obviously, could have given a little smile, or her. So it transmits that heat across space. Now, space obviously is empty; it's a vacuum. So this is the only way that heat energy can move through a vacuum, okay, as radiation. The next way is conduction. Okay, so if I drew a solid, a piece of metal maybe, okay, you might well in engineering or some other lesson learn about transferring of heat, how you can tell that something is a certain temperature. Okay, so you'll get, if we heat one end of a piece of metal, for example, then you'll get heat transferring down it, and that's via conduction. Okay, and we'll talk about that in more detail in a future topic. I'll just put a little flame there so we know what we're doing. Okay, which is why particularly metals, if you pick a piece of metal up, it will feel cold to start with, but quite quickly it will start to heat up. And if you hold a piece of metal in a flame, then obviously it's going to get hot quite quickly, and it heats up by conduction. And the final way is in fluids, and that's called convection. Okay, so convection happens in fluids. I'm just going to make a note of this because a lot of people don't know what a fluid is. But a fluid, or they associate fluids with liquids, which is correct. Okay, but it's liquid. Okay, so like that, there's my liquid. But it's also a gas. Okay, so it's anything that can flow. So I'll just draw some, I don't know if that looks a bit like a gas, doesn't it? There we go. Okay. And to symbolise convection, I'm going to draw a classic kettle. Alright, like that. And we'll obviously have a bit of steam coming out the top of there. Alright. There we go. Okay, so that's it. That's some ideas about energy. What energy is, something that happens, when something happens, energy is transferred, or the ability to do work. Okay, some ideas about how energy could be stored, okay, and some example of energy stores. And then we've got some ideas about how to transfer energy through electrical current, through heating. Okay, we will expand upon those in later sessions. I hope that's been useful, and if you've got any questions, just ping me an email and I'll get back to you. All right, cheers, bye.